Hello, this is going to be week 24 video for our skills practice page. And what we're going to be doing here is seeing a variety of situations with linear equations and things like that. Okay? All right, so one problem that's particularly tricky on here, otherwise I think we'll feel good about the ones from class, is number 6 down here. Now we know we're used to seeing these as y equals mx plus b, where we have our m as our rise over run and our b as our y-intercept. All right, but when I look at this problem, I don't see a y-intercept value over here. All right, that tells me that we are starting at 0. All right, and then I also don't see a number with the x, right? I don't see that. That means it's an invisible 1, right? And we can always put a number over an invisible 1. All right, so this is telling us to start at 0 and go up 1 over 1. All right, so up 1 over and over again, or down 1 to the left 1. Right, now with that, we can get it graphed. All right, so page 2 is going to be graphing two lines at the same time and seeing where they cross over. Right, so what we'll look at here is our number 5. So this problem here tells me to start at a positive 5. So right there at the top. And it tells me to go up 1 and to the right. But since I cannot go up and to the right, I'm going to have to go down and to the left. Right, because up's positive, to the right's positive. But if I can go the opposite of both, down's negative, to the left is negative, and we know that that double negative turns into a positive. Right, so I can go down 1, to the left 2, down 1, to the left 2. And you can see that now all of these are linked with an up 1 over 2 type situation. Okay, this equation here wants us to start at a negative 1, wants us to go down 5 to the right 2. I can't go down 5 to the right 2, so I'm going to go up 2. Up 5 to the left 2. All right, and I see that both of these lines share a coordinate point right here. So that's going to be my answer. And it is a negative 2, 4. All right, and there it is. All right, so this page here, it's all about taking our tables, right, and plugging in the numbers for x in for x. Right, so say I'm going to work on number 5 right here. Right, what I'm going to do to find these different values is plug this number into my equation. So instead of an x plus 3, I'm going to plug in a negative 7. Right, negative 7 plus 3 gives me a negative 4. Right, instead of my x plus 3, I need a negative 2 plus 3. It gives me a 1. Right here I can plug in a 0. 0 plus 3 gives me a 3. 1 plus 3 gives me a 4. Right, and what this tells us is the different values that we can use to plot our equation. Right, and could we also plot this using our y-intercept and our slope? Absolutely. And this one wanted us to calculate some coordinate points along with it. So negative 7, negative 4 would be right there. All right, this is a negative 2, negative 1. So negative 2, negative 1. This is a 0, 3. All right, and sorry, this is a wrong point here. This is a negative 2 and a positive 1. It's a negative 2, positive 1. Notice how I knew this was wrong when it did not match up with the line for the rest of my coordinate points. Right, all these coordinate points should fall on a line. Since this one didn't, I knew that I'd messed up somewhere. This is a 1 and a 4, so here's our 1, and then up 1, 2, 3. All right, you'll know you're right if all of your coordinate points fall onto the exact same line. All right, good. Now this here showed us how to do it on our calculator in class. If we are outside of class, it's the same concept as the other page, except we're just going to be plugging in the numbers that it wants us to for x, regardless of what type of equation we're given. Right? So if I'm looking here at number 4, I'm going to take my equation, but everywhere instead of an x, I'm going to plug in these different values. Alright, so right here, this would just be a positive 2. Right, but instead of this x, I'm going to plug in this negative 2. Raise it to the third power. Whatever all this is equal to, that's what goes there. So negative 2 to the third power gives me a negative 8. Negative 8 times the 2 gives me a negative 16. Alright, so for this one here, it's the exact same thing as my original equation, but instead of the x, I'm going to plug in a negative 1. Negative 1 to the third power is a negative 1. Negative 1, 2 times 2 is a negative 2. Alright, so you can see the pattern. It's just the exact same equation over and over again with different numbers plugged in. Alright, and that's what our equation would look like right there. Oh, sorry. I messed up on this one. I messed up on this one because I forgot to write it is to the third power. 3 to the third power is 27. 27 times 2 gives us a 54.